Hello, Uggies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today, at the request of one of our Uggies, I'm going to talk today a little bit, very quickly, about decibels. We see the term thrown around, and it's not just a ham radio term. It's used throughout science where there is any radio signal or voice signal or whatever. He points out in his question, this is Denna Siegel. Anyway, Denna Siegel asks the questions about decibels, pointing out that he has seen them before in audio electronics, and they are everywhere. They're everywhere. The term decibel, actually, first of all, it's deci. Okay, that's 1/10 of something. And then the thing it's 1/10 of is a bell. Okay, a bell is a power of 10. And it is some power of 10 to the 3. Then if it's 1,000 times, you've got 3 bells. Okay, but it's more convenient to work in decibels, or 1/10 of a bell. Okay, so one bell is equivalent to 10 dB, which is a factor of times 10, okay? So what we're doing basically is taking the exponent. So 10 to the third, so one bell, one decibel, and it's usually abbreviated decibel. This is the actual unit right here, the bell, so it's capitalized. 1 decibel is a factor of 1. Okay, 3 decibel is a factor of 2. 10 decibel is a factor of 10. 20 is a factor of 100. See, 1 0 after here. 20 decibel, 2, you got 2 zeros there, right? So 30 decibel, dB, is a factor of 1,000. You got 1, 2, 3 right there in 30 decibels. Now, right from this, you can see the advantage of decibels. Here, this you go from 1 to 1,000, and you actually only go up from 1 to 30. You see how the decibels cramp down the scale right here. So if you've got 1,000 times 1,000, that's 30 dB, and you add them, 30 dB, to get 60 dB for a million. There's another 0 in there. There's 6 zeros, hence 60 dB. Okay? Now, the cool thing about decibels, they're based on logarithms. And as you recall from your high school algebra class, the one day you absolutely hated it, okay, if you take an amplifier that multiplies by 100 times, 10 to the 2 equals 10 squared is 100, okay? So it amplifies by a factor of 100. And then you've got another amplifier that multiplies by 1,000. You've got 1,000. Now, you normally would multiply this by this because this multiplies this. So you get 100, and you add 3 more zeros. And you have 5 zeros, so that's 10 to the 5th. In other words, an amplifier that doubles, okay? Now, this is kind of in bells kind of thing. We want to look at it ham radio-wise, okay? Suppose I have an amplifier, and it has a 20 dB gain, okay? And then that goes into an amplifier with 30 dB gain. Well, the equivalent to this, 20 plus 30 is 50 dB, which is the 100,000 that we got before. 5 zeros. 5 zeros. Okay. Now, the nice thing, we use this, you see this used in audio. For example, if you have an attenuator and it's minus 20 dB, then the signal comes in here at, say, 15 dB referenced to the A audio scale. Okay, the A audio scale is a curve developed by the Bell system for telephone use. You've got an attenuator, a minus, so this comes out of here at minus 5 dB A. The A again is the A-weighted audio. A-weighted audio is something that the Bell Labs put together a long time ago to show the equivalent of human speech. And human speech is sensitive to midtones and stuff, and gets less sensitive at high frequencies. I think the curve looks something like this. It's been a while since I've looked it up. But the low frequencies don't count so much, the high frequencies don't count so much. It's in the middle, and in fact, the standard bandwidth for communications is 300 hertz to 3000 hertz, which is a 2700 hertz bandwidth. And that's what's used for what's called toll grade telephone that happens to be the same bandwidth we use in ham radio. Okay. Now let's look at this in other things that you can do. You have seen the term dBm. This is decibels referenced to 1 milliwatt. Milliwatt right there. Okay, dBm. This 1 dBm, 1 milliwatt is 0 dBm. Okay, so if you see the 0 dBm, that means it's not changed from dBm. This is an actual power measurement. It's not just a ratio. Okay? When I say ratio, we look at the definition of X decibels equals log 10 A divided by log 10B. No, that's not right. Log base 10, the ratio of A and B. Okay. And that is the number of decibels. Okay, so it's a ratio. But when we're doing dBm, we put 1 milliwatt down here. It's a ratio to 1 milliwatt. Now, if you've got 1 milliwatt here, you've got 1. The log 10 of 1 equals 0. So if I have a 1 milliwatt transmitter, which is pretty low power, I have a 0 dBm. Now we can reference all kinds of things here to the number of dBm. So let's suppose we have 30 dBm. Okay, 30 dBs is a factor of 1,000 because you got 3 zeros. Okay, so that would be the equivalent of 1 watt, which equals 1,000 milliwatts. Okay, so let's say a 4-watt amplifier. Here's a couple neat things about decibels. You can add the decibels instead of multiplying them out. So if I have a 5-watt, now let's make it a 6-watt amp. 6 watts equals 6,000 milliwatts. We can take the 30 times, let's see, I'm doing this wrong. So if we have an amplifier, if we have a QRP rig that's 4 watts, there's an interesting fact about decibels. The factor of 2 means that you add 3 dB. Okay, a factor of 10 means you add 10 dB. Okay, these are very handy things to know. So we're going to take this 1 watt that is 30 dBm, 30 dBm, and we're going to double it to 2 watts, so we add 3 dB. We're going to double it again to 4 watts, and we're going to add another 3 dB, and you get 36 dBm is the power output of your 4 watt transceiver. Now I can go the other way too. Let's suppose you have a microwatt, 1 microwatt. Okay, you start out with 0 dBm, and you've got 1,000 below that, so you're going to subtract 30 dB. Okay, this is the multiplying factor, this is the actual unit, and so 1 microwatt minus 30 dB. Okay, now you can see that we're handling very small amounts of power with relative ease in decibels here. If we want to go 1 femtowatt, let's see, what's micro, milli. The next one is not femto, it's nanowatt. So 1 nanowatt, we just subtract 10 more dB. No, 30 more dB, because that's a factor of 30 dB. And we come up with minus 60 dB for 1 nanowatt. Okay, so you can see that you've got very easy to deal with very small signals and very big signals on a relatively easy to deal with scale. In fact, so much so that people will often refer to a transmitter by how many dBm it is, rather than saying how many watts. You can quickly figure out the number of watts. So there is a very, 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 very short overview of decibels. The idea of a decibel is it uses a logarithmic scale, and you can remember all the stuff you want to. Look it up on Wikipedia if you want more detail. There's also more detail in the licensing manuals where it talks about dBm. This is just a very quick overview to kind of motivate why we use decibels, because it really compresses extremely large numbers and extremely small numbers in fairly decent ranges. This is very good for when you're doing things like receiver building and so on. Remember that we receive signals that are on the order of less than a microwatt, and we're going to put out to the speaker a couple watts. Okay, so there's a tremendous amount of signal amplification in there. It's done in multiple stages. Each stage has a certain dB gain. So there you have it. So I hope this answers the question from Dina Siegel, and that is why we use decibels. Decibels are used to indicate ratios in many fields of science. So that, I hope, answers the question. So there you have it. We have a giveaway going on this month for October 2019 through the last Thursday in October. If you will send a postcard, a QSL card, or a single-page letter to Dave Kassler, KE0OG, P.O. Box 98, Ridgeway, Colorado 81432. And inside, put your name, call sign, phone number, and the address you would like it shipped to. And this is what the giveaway is this right here. This is a really cool little QRP transceiver. It's the Micro BITX by HF SIGs. It actually comes out of India. And it's a nice little all-band transceiver. It will do either CW or voice. Okay? And it doesn't take very much power, and it's a fun little thing to play with. That's our giveaway. So, until we next meet, please subscribe, please click like, and we'll see you later, 73.